These notes are for Algebra 3, Section 4.3, Properties of Logarithms. This is Unit 7, Exponential and Logarithmic Functions. For this section of the unit, we're going to go ahead and look at properties of logarithms. And these are very important properties because you have to master this section in order to be truly successful in the next section where we're going to solve exponential and logarithmic functions. So this is the same properties in exponents as it is in logarithms. This is saying that the log base b of m multiplied by n, so multiplication, that's why it's called product rule. I can break this apart and say, well, this is log base b of m plus log base b of n. So if you were multiplying exponents, say I had x squared times x to the fourth, I'm going to add the exponents and I'm going to get x to the sixth. So it's the same property with logarithms. So an example would be if I had log base 2 of 5x. Well, that 5 is being multiplied by the x, or x being multiplied by the 5. So that means I can use this product rule. So I'd have log base 2 of 5 plus log base 2 of x. Another example, say I had log 4xy. Well, it's three things being multiplied, but that's okay. It's still going to be addition. I don't have the base written, so it's a common log base 10. So this would be log 4 plus log x plus log y. The quotient rule is saying that if you divide two terms, you can expand it and subtract. So if I had x to the fifth divided by x cubed, 5 minus 3 is 2. So this is equal to x squared. So that's the exponential property that goes with this. So an example would be if I have log base 7 of 17 divided by 5. I can rewrite that as log base 7 of 17 minus log base 7 of 5. Here's another example. If I had log, once again I'm going to use common log, so I'm not going to write the base, 5 divided by 2x. This is where some students start getting a little confused, and you just have to be a little bit more careful. This is saying that 5 is divided by the 2 and the x. So there's a couple different ways to write this. I could say this is log 5 minus log 2 plus log x. And that parenthesis shows me that everything is divided by this 2 and this x. Or I could write it as log 5 minus log 2 minus log x. Either one of those is correct, and it just depends on what you prefer. The last property is a power property. So if I had x squared to the 6th power, that's x squared 6 times. X squared multiplied by x squared, multiplied by x squared, multiplied by x squared, and so on for 6 times. If you multiply, you add exponents. But if I'm adding exponent of 2 6 times, I'm actually going to multiply these. So this is x to the 12th. So one example would be log base 4 3 squared. I could make this log base 4 of 9, but in this case I want to show you the property. So this is going to put the 2 out front, multiplied by log base 4 of 3. If I have more terms, say I had log 10x cubed. Well, the first thing I see is the product rule because the 10 is being multiplied by the x cubed. Be careful, that 3 is only the exponent on the variable x. Do not bring that in front. You're going to have to do it this way. So log 10 plus log x cubed. Now I can use my power rule. This 3 comes in front, so I have log 10 plus 3 log x. And then at this point also I want you to start recognizing if you can simplify a logarithm. Log 10, well, since this is a base of 10 and the property says log base b of b equals 1, log base 10 of 10 is equal to 1. So I'd have 1 plus 3 log x. Okay, to use these properties, we're going to expand and condense logarithms. And I'm going to give you a couple examples here, but I'll give more examples during live lessons, and I'm going to give you a lot of practice on this. So 3x squared. Well, 3 is being multiplied by x squared, and the exponent of 2 is only on the x. So when I expand this, I'm going to have log base 2 of 3 plus log base 2 of x squared. I can now take this exponent and put it in front. Log base 2 of 3 plus 2 log base 2 of x. Now this one is division. I've got the square root of x divided by by y cubed. So that means I'm going to use the quotient rule. I'm going to subtract log square root of x minus log y cubed. We've talked about this already this unit. Square root of x is the 1/2 power. I can rewrite this as x to the 1/2 minus log y cubed. Now I have a power rule because I have an exponent, so this 1/2 is going to come in front, and so is the 3. The purpose for expanding and condensing these is for solving the equations. So that's the whole purpose for doing these. Okay, now I want to condense them. So I have to make sure I work in kind of order of operations. You know, if you're really good at this, you could do this all in one step. I'm not going to explain it in one step. I see an addition, so I know I'm going to multiply. I see a subtraction, so I know I'm going to divide. But I see this 2, so I know I need an exponent. So I'm just going to go ahead and do this step by step. Log base 3 of 4 plus log base 3 of x minus log base 3 of z squared. And then I feel the easiest way to write this, I only want to write the word log base 3 one time. Anything being added is going to be multiplied. So 4 plus x means it's multiplied. Anything subtracted means it's divided. The next example, I have a subtraction. Oh, and here's a power rule again. So let's clean that up first. And that's to the 3/4 power. Now I have a subtraction, so I know I'm going to divide. And you can leave it like that. Some people prefer it like this, or you can rewrite this rational exponent as 7 over the 4th root of x cubed. It doesn't matter which way. They're both acceptable. It depends on what you're doing with it, what you're more comfortable with. So that's a few examples for the properties expanding and condensing.